today we're going to apply all the stuff that we have talked about so far with like your multiplying and doing the box method and stuff to finding perimeter and area of different shapes now. So we did perimeter and area at the beginning of the semester with just like combining like terms, right? So now we're going to do more of that because like when it came to, or mostly we did perimeter at the beginning, right? Because we didn't know how to multiply stuff. But now we know how to, so we're going to go back and do some more of that. So the first thing that it wants us to do is multiply these expressions up here, and they are big. Yeah, so you're going to need something else to write on. I don't have anything else to write on, so I'm going to grab this thing real quick. Because I don't have room up there. Y'all have room up there? You can use the back of your bell ringer if you still have that. I threw mine away, so I do not. But if we're looking at number 1, we are multiplying a what? What is this first one called? How many terms? 2 terms, so it's a binomial. So a binomial times a what? Trinomial. So how big does our box need to be? 2 by 3. 2 by 3. I don't know if that's what we said the first time or not, but we need a 2 by 3 box. So let's get that going. Mine's gonna be a little squished. Oh well. So what is 3x squared times 2x? 6x cubed. Is that okay? So what is 2x times negative 7x? Negative 14x squared. Good. And then 2x times 9. 18x. So what about 7x or 3x squared times 7? 21x squared. And then negative 7x times 7. 49 what? X. And then 7 times 9? 63. What do we have to do from there? Combine your like terms. So they're on our diagonal, yeah? What like terms do we have? And then we got 18x and negative 49x. Is that okay? So we're going to have that 6x cubed. That'll still be there. And then when we combine negative 14x squared plus 21x squared, what is that? 7x squared. Then we've got 18x minus 49x. And plus 63. Is that alright? Any questions right now? Okie dokie. So we're going to do the same thing for number 2. But what do we have going on this time? We got a trinomial times another trinomial. So how big does our box need to be? 3 by 3. Get a real big box this time. Like we're playing tic-tac-toe. So we'll have 6x squared minus 3x plus 9. So what is 6x squared times 4x squared? 24x to the 4th. And then what about 6x squared times 5x? 30x cubed. And 6x squared times negative 1? Then what about 4x squared times negative 3x? Then negative 3x times 5x? Negative 3x times negative 1. 9 times 4x squared. 9 times 5x. And 9 times negative 1. Oh my goodness, that about wore me out. So we still have to combine like terms, right? What like terms do we have this time? 30x cubed, negative 12x cubed. I'm going to go ahead and start writing our answer up here. So we got 24x to the 4th. Then what's 30x cubed minus 12x cubed? Okay, what other like terms can we combine? So what's negative 6 and negative 15? Negative 21, so 36 minus 21 gives you is that alright? Do we have any other like terms we can combine? So what is 3x plus 45x? Then we have that minus 9. Is that alright? Questions on any of that? So that's just to warm you up a little bit, review what we were doing yesterday. So like I said earlier, we're going to kind of apply all that to more stuff now. So for this first section, we're just finding perimeter. So how do you find like the perimeter of a rectangle or a square? Out of all our sides. So we have 2 sides labeled. The other 2 sides are not. So what might be a good idea? I would label them just so we know what's going on. So what is this side length going to be? 3x. And what about over here? 3x also. So when we add those all up, what is 3x plus 3x? 6x plus 3 more x. 9x plus 3 more x. 12x. So your whole perimeter there is 12x. So where do we want to write this? Let's say P equals 12x. Is that okay? Is it alright with y'all if we skip to number 3 and do that one real quick? Okay. So for number 3, this is a rectangle, yeah? So how you find the perimeter of a rectangle? Add up all your sides. So we have 2 labeled. What should we do with the 2 that are not labeled? Label them. So what would this top side be? 2x plus 7. What would the other missing side be? 5x. Good. And then we gotta add it all together. So we could basically just combine like terms here, right? So 2 plus 5. 7 plus 2 more. 9 plus 5. 14, so we got 14x. And then we had a 7 and a 7, so what's that? 14. Bailey? Hey. Sure. See if y'all could figure out number 5 on your own. Can we try that one real quick? You have one side that's missing, so what should you probably do? Label it. What do you think that missing side is going to be? X plus Y, yeah. So we're going to add up all those sides. We're collecting like terms or combining like terms. So what are some like terms we have there? Like terms. Thomas, what are some like terms that we have here? Okay, what is 4x plus 7x? Okay, any other x's we could add? So 12x and 13x? Yeah? So we got 13x. Okay. Natalie, what are some other like terms we have there? Y and y. So what is y plus y, y'all? 2y. So we'll have a plus 2y. Any other like terms or anything we're missing? We just need to include that negative 2. Good. Is that okay? Questions on any of that? Okay, cool. So let's look at number 4. We're kind of jumping all over the place, y'all. Sorry. Now, this triangle, it's almost all labeled. We're going to assume that it's isosceles, so both of these legs are the same. So what should we label this side as well? 4x minus 1. And to find your perimeter, what are we doing? Add all your sides, combine your like terms. So let's see, Austin, what are some like terms we have there? 4x and what else? 4x, 6x. So 6 and 4 gives us 10 plus 4 more, 14. So we got 14x. And then let's see, Megan, what other like terms can we combine? -1, -1. What do we get? -2. Any other terms we can combine that with? That 5. So it's 5 minus 2. 3. So we'll have 14x plus 3 there. Is that all right? Questions? Okay, so now we have the tricky ones. We just have circles left. So if I'm looking like at number 2, we want to know the perimeter of a circle. We have a fancy word for that. Do y'all know what it is? Yeah, it's your circumference. Look at you, gold star. So your circumference, do y'all remember how to find that? Pi r squared is your area. So let's just hold the phone. We're going to come right here where it says formulas for area, and we've got circle. Can we go ahead and fill that in for circle? Because y'all are killing it. So we know that when we get there, that's going to be pi r squared. So that's your area formula. How are we going to find your circumference? You do something. Kind of. So your circumference, let's write this at the top of our page. I'm going to spell this wrong. CircumFerence. Does that sound right? We'll go with it. Your circumference is 2 pi r. So it's super close to your area formula. Because like area was pi r squared. So I think of just bringing that 2 to the front to get your circumference. That's how like I remember it. So we've got 2 pi r for your circumference. Or some of us were saying like diameter times pi. So your diameter is twice your radius, or your radius is half your diameter. So either way, you're still going to get there. We are given our radius in number 2, right? Because it just cuts from the center to the outside. So we're going to do 2 times our radius times pi. And that's going to give us our circumference. Is that okay? Okay, so I'm going to write that out. We're going to say C equals 2 times pi times your radius. And what is our radius there? (2x). So we can clean that up a little bit and multiply 2 times 2. What do you get? 4. So this whole thing is going to be like 4 pi x. That's your circumference. And we're going to leave the pi in there. Is that okay? So that's a super exact answer. Do y'all remember what pi equals? 3.14. 3.1415926. Not that I expect you to memorize that. But so we could plug in 3.14 for pi and get like a closer number, but we'll just leave it in there for now. Is that okay? All right, so we're going to do the same thing for number 6. So we're still trying to find our circumference, or like your perimeter around that circle. So what's our formula that's going to help us get there? 2 pi r. So circumference equals 2 times pi times your radius. Then what's our radius? 3x plus 1. So this time, what are we going to have to do to like clean that up? Distribute, yeah. So what is 2 pi times 3x? 6 pi x. Is that okay? because that pi is just kind of like a variable, it's like a placeholder for a much larger number. So we're just going to treat it like a variable. And then we've got 2 pi times 1. What is that? Just 2 pi. So that will be our circumference there. No, we're going to leave it at that. Is that okay? Any other questions? Y'all ready to try some area? Yeah. Okay. So we got a bunch of formulas that we need to fill in because area is tricky and it's different for about every shape that you're looking at, right? So what about area of a rectangle? How do you find that? Length times width, yeah? So I'm just going to say length times width. Or some people say like base times height, so if you put that there, that's fine. However you want to write it, I do not care. What about a square? That's length times width again, right? But what do we know about squares? All the sides are the same. So if the length and the width are the same, that's kind of just like the length times the length, or the width times the width, right? So how else could we write that? Yeah, length squared, right? We just learned about all these squareds. That's what squared means. You multiply it by itself. So we could say length squared, or width squared, or side squared. I'm going to put side squared. That way it kind of goes with either one. Is that okay? So I'm going to say s squared. Side squared. Do y'all remember your formula for the area of a triangle? Good. 1/2 times base times height. What about the area of a trapezoid? That one's kind of tricky. So we're going to do 1/2 times base 1 plus base 2 times your height. And then we already had our circle formula filled in. Y'all remember that from earlier. It's pi r squared. Are we good with all those formulas? All right, so let's apply them. Looking at number 1, what shape is that? Rectangle. If we want to find the area, we're going to multiply your length times your width, yeah? So we have a monomial times a trinomial. Do you have to do anything fancy to multiply that out? We can just distribute, right? So what is 7x times 2x squared? 14x cubed. Then we're going to do 7x times 7x. And last we've got 7x times -1. Is that all right? Question? Cool. So moving on to number 2. We've got a square. How did we say we find the area of a square? We can do side times side, or side squared, or length times width. You've already got both your sides labeled. So we've got a binomial times a binomial. We gotta do the box method, yeah? Now I like to kind of cheat a little bit. This is already a box, so I'm just gonna make it our box. That okay? I do what I can. So I'm going to write this one over here just so I can see it a little bit better. So x times x, what do we get? X times x gives us what? X squared. And x times 7, 7x. And 7 times x, 7x. And 7 times 7, 49. What do we do from there? Combine your like terms, so 7x plus 7x You're right. So we're going to have x squared plus 14x plus 49. And that will be our area. Is that okay? Question? Awesome. Y'all want to try the circle or you want to come back to this last? Y'all ready? Okay. So what's our formula for the area of a circle again? Pi r squared. So we're going to say A equals pi times your radius squared. What is our radius this time? 4x cubed, and all that is squared. So do y'all remember from Monday what we said you have to do when you have a bunch of stuff inside parentheses and it's got an exponent on the outside? Everything's going to get that exponent. So are we going to do 4 times 2 or 4 squared? 4 squared? Yeah? So what is 4 squared? 16, so I'm going to put 16, and I'm going to go ahead and put the pi behind that, just because that's probably how you'll see it written. They put it before the variables generally. And then inside those parentheses, we also had x cubed to the second power, or squared. So when you have a power to a power, you multiply. So what is 3 times 2? 6, so that should be x to the 6th. Is that all right? Questions? Cool. Moving on to number 4. So for number 4, we've got a triangle. What's our formula for the area of a triangle? So we're going to say area equals 1/2 times your base. What's our base? 4x. Times our height. And which one's our height? 3x. Do we need that 5x at all? Bless you. Do we need the 5x at all? Nope, it's extra information. Sometimes they give that to you. Okay, don't let it confuse you. You don't need it. So let's think about how we could do this. We've got to multiply all this stuff, right? So we've got to do half of 4x. What is that? 2x. So then we've got 2x times 3x. And what is that? 6x what? Squared. Good. Questions? So this is not too bad, right? No response. It's fine. Alright, so looking at number 5. So that's our trapezoid. So we got that weird formula we have to use there. So I'm going to try to slide it so we can see both at the same time. Is this going to work? Ooh, it's not going to work. I'm going to copy it again. Alright, so that's our formula for the area of a trapezoid. Yeah? So we're going to have A equals 1/2 times, what's base 1? Or one of our bases? 8x plus 3? Plus our second base, or base 2. Which one's our other base? 3x. Then we need our height, which is what? 4x squared. So we can go ahead and combine like terms inside our parentheses. Yeah? What can we combine here? What's that going to give us? 11x plus 3. And then we've got that 4x squared still and a 1/2 out front. So we need to do half times one of these two things. Is it going to be easier to multiply 11 and 3 by 1/2 or 4 by 1/2? 4. So y'all, it's usually going to work out that you'll have one of these two things as an even number. So you can just cut that in half, and that's going to be so much easier than trying to do an odd number divided by 2. Right, doesn't matter, because order of multiplication doesn't matter, right? So do what's easier, not what's harder. So what is half of 4x squared? 2x squared. Yeah? So we're going to have 2x squared times 11x plus 3. I think my pen has finally died. Maybe, maybe not. Can y'all see that? Is it still writing? Not really. So then what's our last step from there? Distribute. So what is 2x squared times 11x? 22x cubed, and then 2x squared times 3? 6x squared. Is that all right? So that's our final answer there. Questions on that one? That one was kind of long, but it wasn't too hard, right? Okay, so the last one we got there is another circle. So remind me our formula for the area of a circle. So we've got A equals pi r squared. So what is our radius this time? So yeah, what's our radius? 4x plus 3. So we have 4x plus 3 squared. So y'all, when you have a binomial squared, what do you have to do with that? Multiply by itself. So we have to write it twice and do the box. Yeah? So anytime you have a binomial squared, write it twice, do the box. Yeah? So we are going to do that here. We'll have pi, then 4x plus 3 times itself, so 4x plus 3 again. And we're going to have to do the box method to multiply that out. So I'm going to come over here for our box. So what is 4x plus 4x? Or times 4x. 4x times 4x. 16x squared. What is 4x times 3? 12x. 4x times 3 again. 12x. And 3 times 3? 9. Combine your like terms to the middle. So we're going to have pi times 16x squared plus 24x plus 9. I definitely ran out of room there. So we can distribute that pi if you want to, and we can call that 16 pi x squared plus 24 pi x plus 9 pi. Or you could have just left it here. Either way is fine. I don't mind which one you do. Questions on that? So anytime you have a binomial square, what are you going to do? Do the box. Write it twice. Do the box. Every time. Questions on anything? So we're going to start doing stuff that's a little bit different. So on the back, we are given the perimeter and one of the sides. So we've got to find the missing side. How do y'all think we could go about doing that? We could subtract the sides we do know, and then we'll have the two sides left over. So how are we going to find just one? What about 2? Is that okay? So let's label this side, because we already know that this one's also going to be x minus 5. So then we're going to take our perimeter, which is 16x minus 4, and we're going to subtract the two sides that we do have. So when we add these two sides together, combine your like terms. So x plus x gives you 2x. And negative 5 is going to be minus 10. So what is 16x minus 2x? 14x. And what is negative 4 minus negative 10? when you minus a negative, what are you really doing? So this is like negative 4 plus 10. Plus 6. Because you're doing negative 4 minus negative 10. And when we minus a negative, you're adding. So negative 4 plus 10 is 6. They're not both negative. It's because it's negative 4 minus negative 10. This is what you have going on there. Negative 4 minus negative 10. And when you minus a negative, what are you doing? Adding. So this number, this expression, is these two sides added together. So how are we going to find just one of them? Divide by 2. So what's 14x divided by 2? And 6 divided by 2? 3. So one missing side is 7x plus 3. That okay? How could you check your answer to be sure you're right? Yeah, so like label your two sides that we're missing, add them all together, and we should come back to the same perimeter. Do we need to do that? So number 2 is now giving you the area and one of your sides, and we're missing one. So how do you find area? We would multiply your two sides, and we'd get this answer, right? So how are we going to work backwards? Divide by what we know. That'll tell us what's missing. Yeah? Is that okay? So we're going to do 3x squared plus 6x and divide that whole thing by 3x, because that's the one side that we already know. So I'm going to break this up into two fractions. That's a little bit easier for us to look at. So that's the same thing as having 3x squared divided by 3x plus 6x divided by 3x. So what is 3 divided by 3? 1 cancels, right? And what is x squared divided by x? Just x, right? Y'all remember when we're dividing in terms of like bases, you subtract your exponents. So 2 minus 1 is just going to give us 1, so that's going to be x. Plus, what is 6 divided by 3? 2. And then x divided by x. Remember, subtract your exponents, so 1 minus 1, what do you get? 1 minus 1 gives you 0, so x to the 0 power is 1, so 2 times 1 is just 2, so those kind of cancel, right? So that side we're missing is just x plus 2. How could we check our answer there? Multiply out. So 3x times x plus 2. What is 3x times x? 3x squared. What is 3x times 2? 6x. So that checks out. So we're good to go. Is that all right? Questions? Alrighty. So now we're going to do some word problems. Everybody's favorite. So Jake's got a rectangular vegetable garden that is x plus 8 feet long and 2x minus 4 feet wide. I'm going to stop us right there. Anytime you see or hear a shape word, what should you do? Draw it. So let's do that. I'm going to go ahead and draw our rectangle. And then, do they tell us some stuff about the rectangle or the garden? What do they tell us? X plus 8 feet long. So I'm going to put x plus 8, and then 2x minus 4. I think we have them. She had them for first block, so I don't know. Sorry. So we know what we're talking about now, right? We got our little vegetable garden and it's all labeled. So let's see what they want us to find. It says, so how much fencing does he need to completely enclose the garden? So if they're talking about fencing, is that going to be like area or perimeter? Perimeter, right? Because your fence is going to go along the outside. How do you find perimeter? Add up all our sides. So what are some like terms we can combine there? X and x gives you plus 2 more x plus 2 more x, 6x. What else can we combine? What is 8 plus 8? Minus 4? Minus 4 more? 8. So 6x plus 8 is going to be our perimeter. Is that alright? Okay, so the next part wants us to find the area. How do you find the area? Multiply length times width. So to do that, you're going to have a binomial times a binomial. What do you have to do to multiply that out? The box. Do you want me to use the box we already drew? I think I'm going to. If yours is too small, then you don't have to. What is 2x times x? Tori, what's 2x times x? Yep, 2x squared. Then we're going to do 2x times 8. What is that, Riley? Good, 16x. Julia, what is negative 4 times x? Negative 4x. And Noah, what is negative 4 times 8? Negative what? 32, good. What do we do from there? Combine like terms. So we're going to have 2x squared. Then 16x minus 4x. What is that? 12x minus 32. And that's our area. Is that alright? Questions on anything? So the next one, we've got this funky shape going on here. Well, it's not really funky, it's just a rectangle, and then another rectangle's been cut out of it. And we want to find the area of just the shaded region. How can we do that? Yeah, we can do the area of the big rectangle, then subtract the area of the small rectangle. That sound okay with y'all? So I'm going to write that. I'm going to write the big one minus the small one. That's our plan here. So how are we going to find the area of the big rectangle? The box. So I'm going to come over here and do that. We've got 2x plus 5, 3x plus 1. Haley, what's 2x times 3x? 6x squared. Bailey, what's 2x times 1? 2x times 1? There you go. Abigail, what is 3x times 5? 15x. And Sierra, what's 5 times 1? There you go. What do we do from there? Combine your like terms. So 2x plus 15x. So for our big rectangle, we're going to have 6x squared plus 17x plus 5. Now we need to find the area of our smaller rectangle. So let's look back at our shape. We had x and then x plus 2 for our side lengths there. Do you have to do anything fancy to multiply that out? Just distribute, right? So what is x times x? X times x gives us what? X squared. And then x times 2 gives us 2x. So make sure that we're subtracting that entire square. So you've got to use parentheses around there. So to clear those parentheses, what are we doing? Distribute what? A negative 1. So distribute that negative 1. That's just going to change our signs. So we've got 16x squared plus 17x plus 5. Instead of a positive x squared, we'll have a negative x squared. Instead of a positive 2x, we'll have negative 2x. And what do we do from there? Subtract, just combine your like terms, yeah? So what are some like terms we have going on? So what is 6x squared minus 1x squared? 5x squared. Any other like terms? 17x minus 2x. What's 17 minus 2? So plus 15x. Then we still had that 5 hanging out, so we'll write plus 5. Questions on that? Alright. Moving on to number 3. So we're going to paint a rectangular wall. I'm going to stop right there. What should we do? Draw a rectangle. It's got a length of 5x squared and a width of 12x. So let's go ahead and label that. The length is 5x squared and the width is 12x. So then it says there's a rectangular door that measures x by 2x that will not be painted. So how could we draw that on here? Draw a little door, label it x and 2x. It wants to know the area of the wall that will be painted. So how are we going to figure that out? The big one minus the small one again, or the whole wall minus the door, right? Because you're not going to paint the door. So we'll do wall minus the door. How are we going to find the area of the wall? 12x times 5x squared. So what is 12 times 5? 60. X squared times x is x cubed. And we're going to subtract the door. How would we find the area of the door? 2x times x. What is that? 2x squared. Is there anything else we can do with that? Any terms we can combine? Nope, so we're all done. That's your final answer. Questions? Alright, y'all, we're almost done. I know y'all are getting tired. I can see it in your faces. So the next one, it says a flat square roof. I'm going to pause. What should we do? Draw a square. So our flat square roof needs a square patch in the corner. So pick a corner. We need to put a patch there. The side length of the roof is x plus 12. So we know that one side is 12, and since this is x plus 12. Since it's a square, what's the other side going to be? X plus 12. The side length of the patch is x, so our patch is also a square. So if one side is x, what's the other side going to be? X. It wants to know the area of the good part of the roof that doesn't need to be patched. So how are we going to find that? Subtract again. So we're going to take the whole roof and subtract the patch. Is that okay? So we're going to do the roof minus the patch. How are we going to find the area of the roof? X plus 12 times x plus 12. What do you have to use to multiply that out? The box. Keelan, what's x times x? Just x times x. So it's just x squared. Good. Ethan, what's x times 12? 12x. Then we got x times 12 again, so 12x again. Chloe, what's 12 times 12? Good. 144. What do we do from there? Combine your like terms. So the area of our roof is x squared plus 24x plus 144. Then we have to subtract the patch. Now, how big was the patch? X times x, right? So what is x times x? X. So we can just subtract x squared. Can we combine any like terms? Ah, we've got a 1x squared minus an x squared. What's going to happen? They cancel out, they go away, and we're just left with 24x plus 144. And that is our final answer. Bless you. Questions there? Alright, last one. We're almost done. So a helicopter landing pad is sometimes marked with a circle inside a square. It's already drawn for you, so you don't have to draw that. So that it is visible from the air. What is the area of the shaded region of the helipad? We're going to pretend that this is the shaded region. So you got to kind of color yours a little bit. So if we want to know just the shaded region, so it's basically the shaded corners there, how can we find that? Yeah, can we just do the area of the square minus the area of the circle? Yeah, so let's do that. So how do you find the area of a square? Length times width, 2x times 2x, or we could say 2x squared, right? I'm going to write it that way. So 2x squared minus, how are we going to find the area of our circle? Pi r squared. What is our r right now? X, so pi x squared. Is that okay? So when we have a bunch of stuff inside parentheses and an exponent on the outside, what do you have to do? Kind of distribute that exponent, give it to everything. So we're going to do 2 squared, which is what? 4. And then x squared, which is the x squared. Is that alright? Then we have pi x squared over here. Is there anything we can do with that? Nope, so I'm just going to say minus pi x squared. Now technically those are like terms, right? Because they both got x squared on them. But if we like combine those, you just have 4 minus pi x squared, which is not really written any easier. So are y'all okay if we just leave it like that? Yeah? Okay. So we'll leave it there, call that our final answer. Do you have questions on anything?